Hello InfoPerson, this is Anton, and today we're going to discuss a somewhat hypothetical concept of Blanets, black hole planets. Something that might not make sense at first, but something that a lot of scientists have been investigating in some of the recent studies, because some researchers now believe that black holes, especially really large ones, are not just these cosmic monsters ripping everything apart and potentially swallowing everything, but instead they might actually be extremely prolific planet nurseries and maybe even represent some of the most planet-rich regions in the entire galaxy. And some of these planets, because of various effects around black holes, even have a chance of maybe containing habitable conditions. And so in this video, we're going to discuss a few studies that essentially explore these ideas and basically talk about how this works and what implications this might have for our understanding of black holes and, of course, exoplanets. And as always, both of these landmark papers can be found in the description below. But I guess first let's actually start with this Blanet hypothesis, which was only proposed back in 2019 by the Japanese researchers. Researchers who wanted to figure out if some of the most extreme environments in the universe can possibly create planets and even maintain planets in ways we could never imagine. And well, as the name implies, a planet is a black hole planet. So basically these hypothetical exoplanets that orbit a black hole instead of a star. And this idea started to gain formal scientific traction around 2019. This was when a team led by Keiichi Wada proposed that some planets can form inside the accretion disk of a typical galactic nuclei, or AGN, or, in simpler terms, a massive black hole with a very large accretion disk. This was in a study in Astrophysical Journal titled Planet Formation Around Supermassive Black Holes in the Active Galactic Nuclei, with the main concept essentially suggesting that some planets can potentially form inside these dense rotating accretion disks from all of the dust and all of the gas that surrounds the active supermassive black hole, but using a slightly different mechanism from how it's usually done around a typical star. And so in a typical star-forming disk, that can sometimes be a few hundred astronomical units in size, generally forms anywhere from a few to possibly a few dozen planets, all with slightly different composition depending on the location in the star system where it eventually formed. But a typical AGN disk can actually stretch for several light years, and thus be thousands and thousands of times larger and possess a lot more material. And so, unlike any standard protoplanetary disk, where gravity initiates the collapse of material, inside this accretion disk, because it's so massive and because some parts of it become so cold, the outer regions actually allow dust grains to collide and eventually coalesce, with some of the first models suggesting that a single supermassive black hole can potentially create thousands of these Blanets in relatively stable orbits and with masses up to about 20 Earth masses in total, with most of them having extremely long orbital periods, hundreds of thousands of years around the black hole. But new modeling involving magnetized disks, or basically accretion disks where the magnetic field is also included, suggests that this number was actually a massive underestimate, because we're now looking at the possibility of tens of millions of these objects forming in a very similar region. Although here I also have to briefly discuss why these outer regions in a typical accretion disk seem to have such an excellent environment to possibly form these objects. Well, for one, the inner disk of a black hole is obviously a little bit too hot. Here the dust actually does not survive very long, and there is just way too much activity for anything stable to form. But further out, anywhere from maybe 3 to 4 light years away and even farther, there's actually a region referred to as the dusty torus, a region that can actually be up to about 40 to 50 light years across. And inside this torus, the temperature drops by so much that minerals and even ice particles start to condense into grains and start to eventually stick together. And because these disks are so massive and so dense, much denser and much more massive than anything in a star system, the growth of these grains becomes very, very efficient and very rapid, which is actually what this recent study from 2026 explores and tries to understand. Here, Bhupendra Mishra and the team you see on the screen use the model referred to as magnetized disk model in order to try to explain how all of this works and what it potentially produces, with one of the main discoveries being that a process referred to as streaming instability basically acting like a trigger. This is where dust grains clump together into these long filaments, with these filaments containing as much mass as the entire star. But instead of one single large object, eventually they basically collapse into millions of tiny planetesimals, ranging in size from size of planet Earth to maybe even some kind of a super Jupiter. And it's these worlds that then start to grow through pebble accretion by effectively scooping up all of the leftovers near them and possibly growing larger and larger as the time goes by. And in these dense environments of a typical AGN, they potentially grow much faster than any planet in a typical star system, very likely evolving in just a few hundred years instead of a few million years. But all of this also leads to some somewhat bizarre results. Since these planets form from this dust component of the disk, they're mostly made out of very heavy elements, with these new models predicting a population of stellar mass rocky objects, or basically objects whose mass is not so different from a typical star, but that are literally made out of planetary stuff. Or just to rephrase this, imagine a planet Earth with the mass of the Sun, made almost entirely out of silicates and metals. And in this case, these objects would extremely likely have very unusual cores, basically degenerate cores, and contain massive magma oceans on their surfaces, making them resemble a kind of a giant lava drop orbiting the supermassive black hole. In other words, at least in theory, some of these planets might be like nothing we've ever imagined, and possibly contain such an extreme environment that it will be very difficult to understand using current models. As a matter of fact, we have no idea what such a planet would look like, or what properties it would produce. But it gets even more interesting, because some of these planets can actually keep growing larger and larger through this process of accretion, and because there's just so much stuff around these black holes, that they then start to accrete massive amounts of gas and might even reach the point of nuclear fusion, which would then define this object as a star. This is basically how star formation usually works, but normally involves just gas in some kind of a nebula. But in this case, we have an object where a star was born from a planet that was basically orbiting a black hole, with research also suggesting that some of these eventually might get so big that they at some point just collapse into black holes and maybe even intermediate mass black holes, several hundred solar masses in mass. In other words, in these regions, some objects might go through some really extreme cycles, eventually resulting in some very exotic objects that we never considered before. But then there's also the question of, okay, well, if there is a planet here, what's the chance of at least one of them potentially containing conditions that might be suitable for life, or at least suitable for liquid water? And that's technically what this older study tries to tackle as well, mostly because since there are so many planets, there's maybe a chance that at least some of them might have some really exciting conditions on the surface. Now, having these habitable planets around supermassive black holes is of course the main premise from the movie Interstellar, and sorry if I spoiled that for you, but in a nutshell, the way that this habitable planet was habitable was because of the effects produced by the black hole. In other words, in the movie, the planet did not have a star, but all of the heat was received from very specific black hole effects and from the illumination by the accretion disk. And so theoretically, if the accretion disk is tuned correctly, it can provide light and heat similar to the sun. But in this new study, Lorenzo Iorio highlights a major problem: the general relativity. In this case, because of the extreme gravity and also because of the spin of the black hole, many of these planets, especially the ones very close to black holes, might also experience what's known as relativistic spin precession, officially referred to as the lens-theory precession. The unusual phenomenon from the general relativity that was officially confirmed when scientists were able to use it to explain the very bizarre Mercury precession that puzzled astronomers for many years. This was actually one of the major confirmations of the general relativity, and is in some sense the result of the phenomenon referred to as frame dragging. This video from David Butler, you can find in the description, explains all of the math involved in here pretty well. But unlike Mercury, that's basically affected by the sun's mass, here these planets would be affected by enormous gravity from the central black hole. And the black hole's gravity exerts such a massive torque that the planetary axis starts to shift quite a lot. As a matter of fact, on a typical planet, this tilt could shift by tens or even hundreds of degrees in just a few hundred years, which for a typical planet that needs stability would be very problematic. It would essentially result in a massive collapse of any climatic conditions. Here this would trigger runaway glaciations and atmospheric evaporation, assuming of course there is liquid water and vapor. And so while the neighborhood itself might be warm enough for some of the water to exist, the seasons here would be extremely chaotic, and the planets would experience quite a lot of dramatic shifts. Or at least for some of the planets much closer to black holes, the ones receiving enough heat where the liquid water can possibly exist. But I guess the last question to answer is, okay, so this is quite interesting and all, but can we actually prove that any of this is real and if they exist? Well, unfortunately, we cannot see them directly yet, because the black hole in general is usually just a little bit too bright. But in theory, we could look for some kind of an occultation or some kind of a micro-lensing effect that can only result from an object passing in front of the black hole and an object with a certain mass. And so if a planet passes in front of a small X-ray emitting region near the center of the black hole, it should create a typical flicker, very similar to a typical gravitational lens we've seen previously. But even though astronomers have been looking for these for quite some time, right now none of the telescopes are sensitive enough to directly detect these eclipses. And though in the past scientists have proposed at least 2 candidates, or these candidate planets from 2 separate locations, here we're talking about a potential planet orbiting a smaller black hole inside the Whirlpool galaxy, and another planet that was potentially destroyed when it approached the central black hole inside NGC 4845. As of today, as of 2026, there is basically no other evidence and no other official detections. But despite of this, it is still intriguing to try to find these objects, because right now this hypothesis suggests that supermassive black holes are not just destroyers and do not just shred things, they're also potentially fundamental to the chemical enrichment of galaxies and to the potential formation of many of these different objects that possibly then influence the environment in the central region and maybe even affect other stars and planets farther away, with the hypothesis right now suggesting that millions of these planets possibly help nucleate a lot of high metallicity clouds in the region that eventually result in the formation of new stars and new additional galactic structures that slowly spread outwards with time. In other words, everything that happens in the center eventually affects the rest of the galaxy. But it's also a reminder that even some of the most extreme environments in the galaxy seem to contain same fundamental laws, specifically the laws involving gravity, magnetism, and dust dynamics, that potentially then result in extremely similar objects that we see everywhere, stars and planets. Which means that we'll definitely discuss this in some of the future videos once there's some additional discoveries. Until then, thank you for watching, subscribe, come back tomorrow to learn something else, support the channel Patreon where you can find additional videos without any ads and can DM me directly, or by joining a channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.